So in this example, I'm going to go over how to solve using the quadratic formula. So our formula is up in the center here. All right, we've got x is equal to the opposite of b plus or minus the square root of b squared minus 4ac, and all of that is divided by 2 times a. So this is what we will use when we're wanting to solve using the quadratic formula. And our a, b, and c values for which we'll have to substitute into this equation come from the standard form of the quadratic equation. So in the first example, we start off with the equation x squared plus 3x is equal to 4. Before I can identify my a, b, and c values, I want to set this equation equal to 0. So in order to do that, we're going to have to move 4 over to the left-hand side. Now that I have all of my terms on one side of the equation, we're going to identify the a, b, and c values. So my a value is the coefficient of the x squared term. For this equation, it's 1. My b value is the coefficient of the x term, which is 3. And my c value is the constant term, which is negative 4. After we identify a, b, and c, we're going to want to take these values and plug them into our quadratic formula. So we have the opposite of b, which is 3, plus or minus the square root of b squared minus 4 times a times c. So all I've done in my numerator is just replace all of my a, b's, and c's with their corresponding values. And then in our denominator, we have 2 times a, or 2 times 1 in this example. Now that we've substituted our a, b, and c values in, we're going to want to start to simplify. So I would have negative 3 plus or minus the square root of 3 squared, which is 9. And then I have negative 4 times 1, which is negative 4. Negative 4 times negative 4 is a positive 16. And that entire thing is all over 2 times 1, which is just 2. I can simplify my radical even more to have negative 3 plus or minus the square root of 25 all over 2. Which can be simplified even further to 5. So we end up having our set of solutions being negative 3 plus or minus 5 divided by 2. From here, since we have all real numbers in our solution, right, I can separate this plus and minus sign to identify my 2 unique solutions. So I have negative 3 plus 5 for my first solution, which is divided by 2. And then in my second solution, I'm going to do the opposite sign, which is negative 3 minus 5 divided by 2. So we can simplify both of these fractions to find our two solutions. Negative 3 plus 5 is 2, which is divided by 2, which gets us 1. And then negative 3 minus 5 is a negative 8, still divided by 2, which can be reduced to negative 4. So our two solutions when we use the quadratic formula are 1 and negative 4.